Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and wonderfully intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT from Weather Risk, the commander of chaos, the colonel of confusion, the captain of catastrophe, and it's time to talk about this week in weather. Well, we've got a lot to talk about here. Changing weather patterns, potential more tropical activity, taking a look at getting more information about the winter, just so much. Let's get right to it. First, just want to talk about briefly about the final tally here from Florence on the confirmed tornadoes here. Um, a lot of them typically, EF0, EF1s, and you can see most of these were in South Carolina, this image, but here, of course, we have the ones in Central Virginia. In my neck of the woods, Chesterfield County, and that was the big EF2 there, and that was the big one which caused all the fuss and killed that person, I believe. And so just wanted to point that out to you. That was quite a bit of tornado activity with the system with Florence as it spun its way down and finally fell apart. All right, let's take a look briefly at September here. September was a warm month. This was for the country as a whole. You can see generally east of the Mississippi River much warmer than west of the Mississippi, and of course off the Appalachians, the deep south, and into the mid-Atlantic states. That orange color is 4 to 6 degrees Fahrenheit above normal. The red 6 to 8 degrees Fahrenheit. So it was one of the warmest Septembers on record for many of us. No doubt about that. If you look at it in enlargement here, we can see that again we can a large area of 6 to 8 degrees Fahrenheit above normal. Sorry, this slide here is a repeat of the previous one. I'm not sure why I had it up. Anyway, what I wanted to show you is this slide here, and this is the rainfall for the past 30 days. And as you can see, the rainfall has been quite impressive. And again, outside of North Carolina with Florence and the hurricane, many areas in Virginia, West Virginia, Kentucky, Maryland, Pennsylvania, New Jersey have had its wettest September record. Interestingly, if you take a look at this here, in Southeast Virginia, they actually missed out on a good portion of the rain. And notice in this whole area in here, you can see the rain really missed out. They got some rain in here, 2, 3, 4, 5 inches. I mean, they were good rains, but they're really super heavy rains. They definitely missed out in that area of Southampton Roads. So that's kind of interesting, I thought. And that's because, as we know, Florence did not come up the coast. In fact, it went this way. And the eastern side of the system collapsed, and you get nearly as much rain over here. So that really what happened with Florence. That's why you're seeing that anomaly there. And if we look at the percentages in rainfall last 30 days, again you can see that actually Hampton Roads, that 2, 3, 4, 5 inches of rain in this area here, that's actually very close to normal for this time of year. And of course, we can see this, 600% above normal in here, and 400 to 600% above normal in there. But it's been, well, very wet, as we know. And again, for many areas, the wettest or the top 10 wettest September on records, without a doubt. All right, let's take a look at some more detail here over the country. This is the last 30 days, and we can see that it has been very wet. This has obviously affected the harvest in the Midwest areas in terms of getting the crop in. Down in here in Texas, it's been pretty wet for the beginning of the winter wheat planting areas, and then across all of the Mid-Atlantic and the Ohio Valley, Eastern Corn Belt areas. And then in Canada has also been pretty wet as well. And if we look at that's the last 30 days, and the last 14 days, more the same. This has been a wet pattern. All right, let's go back and take a look why it's been so wet. I'm getting these questions that are showing up on the Facebook page, and people saying, Dave, what's with the pattern? Why has it been so wet? Why has it been so warm? Well, we can take a look at the pattern here in a number of different ways. Now, these upper maps here, 500 millibars, we will take a look at every few days in September, and we can see what the issue is. We'll start out September 1st. So we have a trough right here. You can see that, and there's our ridge. You see the high pressure here. So that's our ridge. So the jet stream is doing this. Now what that does is that produces a lot of rain in here, but it makes everybody, over the eastern United States, and the rain goes in this direction, but the deep south is quite wet, it's quite warm here. Now this is a fairly active pattern, and what's happened is you can see by September 8th or 9th, the western energy here that was over here has now moved here. and this produced significant rain throughout all the Midwest and eventually the East Coast. We have the Bermuda High here bringing up moisture from the Gulf of Mexico, and meanwhile you're still getting more jet stream energy coming in from the Pacific Ocean. So this was a very active pattern in the first portion of the month. Now here we can take a look and see a bit more detail. This is September 12th and September 18th, and what do we see again? Obviously this is Florence, going from that, and here's our big ridge of high pressure. The hurricane's embedded in that. Look at that deep monster trough for September, very impressive. And because this was such a deep trough here, this high pressure area got stronger, and that forced Florence to go inland. But the point is that, again, this is a warm pattern even without Florence. In other words, so let me clear this out for a second. If we did not have Florence here at all, we still would have had a very strong trough and a strong ridge here, and we've had more rain in the Midwest and more warm temperatures and some rain to the mid-Atlantic states and New England as well. Now down here at the bottom, this is September 18th, and you can see the remains of Florence is finally gone, but again we still have our trough on the west coast and this strong jet stream moving across the Midwest and the Great Lakes in New England, which make for a pretty wet pattern. So there you go. It's been a very active pattern. Now finally we got to September 24th. We see a bit of a ridge developing here. You see this ridge here a little bit, but the trough is still over the Rockies of Western Canada, and we still have another ridge here. So this is where the wet pattern was, the cool pattern. And finally, we got a little cool shot last week. If you recall, last weekend it was delightful. I'm sure you all enjoyed it. And here's our big ridge on the west coast. And there's our big trough coming in here. Finally, some cool air pushing south, which is exactly what we saw happen with many areas getting down to the 50s in the Mid-Atlantic region, even some 40s. So now the point here that I'm trying to make is that a lot of people are complaining about how warm the pattern is. Now let's go over this very, very carefully. Sustained cold weather in the eastern United States in October is meaningless. Stop whining about it. It doesn't matter. Nobody cares. Stop whining. You're looking at the long-term picture here. Why is sustained cold in the eastern U.S. a waste? Why is it meaningless? This is why. Think about it. Sustained cold and winter weather in the eastern U.S. only comes from Canada. Duh. In order to get bitter cold, that Siberian air to come racing across the Arctic region into Canada, you must have Canada being cold with sustained deep snow over Canada. You must have that first. If and when Canada does not have deep snow buildup, those Siberian air masses, when they come over the Arctic region, fall apart and modify very quickly. And the classic example of that is the winter of 2001 and 2002. In that winter, everybody thought that because the eastern U.S. was cold in October, that it was going to be a cold winter. And what happened is there was no cold air buildup and no snow buildup in Canada, and the cold air masses modified very, very quickly, and we ended up with essentially no winter. And that's the problem. So you want Canada to get cold first, okay? Really, really important. Let's take a look at this. These are the temperatures, the anomalies for the US and Canada for the last 30 days. So here we have our min temperatures, and here are max temperatures. Look at these anomalies in Canada. This is very good. Really a big buildup of cold air here. We want to see that. Let's look at the last 14 days. Same sort of thing. Look at those max temperatures in the upper right and the min temperatures in the bottom left. Again, a lot of buildup of very impressive cold air, southwestern, south central, central Canada. This is what you want to see. Very important. Now, for us, it's a little frustrating. Let me show you why. Now, this is a omega ridge, and we call it omega ridge. Let me highlight what I'm talking about here, right there, this feature. See it? Omega ridge. We call it that because it's shaped like the letter omega. Well, duh. Okay, let me change my mark here so you can see what I'm talking about. Make it the red. There you go. So you can see right there. That's the shape of the letter omega. Okay. Now what that does is this drives into the Arctic Circle, and it causes the cold air to pull from the Arctic region into western and southwestern Canada, and allows this to build up in cold air and snow buildup. We have low pressure coming out of this area, tracking along on top of the ridge. Now, over the Midwest, the deep south, in mid-Atlantic states, it gets pretty warm. Okay, but it's very wet pattern for the Midwest and the Great Lakes. But for Canada, it's really, really a good pattern for buildup of snow cover. We can see the temperature anomalies here. Look at the difference, contrast. I mean, it's stunning. uh, you look at that's -8. Okay, that's pretty dry. That's centigrade, folks. By the way, that's 10 degrees Fahrenheit below normal. Yeah, and look how warm it is over the eastern U.S. relative to normal. This is October 10th, October 11th. And we can see what this looks like in the pattern. This is the first cold front comes through on Wednesday through the Midwest, followed by another one. The front pushes south a little bit into the Mid-Atlantic states, a little bit down in here. But we have another wave of low pressure develops, a lot of rain over the Midwest once again. The front stalls there. And here we can see for the weekend, Saturday, and for Sunday, the front's going back and forth. You can see that over the eastern U.S., but the front essentially remains stalled over the plain states of the Midwest. And it produces a lot of rain. And this is now for next week, Monday, October 8th, and doesn't move much, October 9th. The high pressure's off the coast. We're not seeing much. And a lot of rain over the Midwest of the plain states. Now, this is also a really dry pattern, too. If we look at the 6 to 10 day, this is the jet stream pattern. Now, this is the 5-day mean. Okay, so this is over the next 5 days. Okay, and it is the 6 to 10 day. Again, big ridge here, big trough here, great for Western Canada snow buildup. You can see the ridge here. Okay, this is a good pattern. And again, the cold air is pouring south, and there it is here. But strong temperature anomalies, you definitely see that. Okay, and we can see in terms of rainfall, yes, this pattern also means no rain. Look in this map here, not much for the Mid-Atlantic states, not much for the Mid-Atlantic states of New England, not much for the southeastern states. It's the next 10 days look really dry. It's been dry for the last few days, and now we're getting an extended dry interval. And this sort of pattern, we can see it here. This is the 6 GFS for the 6 to 10 day. No rain on the GFS or the GFS ensemble over, really the Mid-Atlantic region right here. And even New England, very little rain. That's really great news. We could use it. The rivers are dropping. The North Carolina rivers are dropping. The ones in Virginia, Maryland, West Virginia, they're all dropping off Pennsylvania. Same sort of thing here. This is the European 6 to 10 day. And again, we can see no significant rain through the next 10 days. You can see that. Okay. That's terrific. That's what we want to see. But the rain in the Midwest looks tremendous. I mean, that's really bad for the harvest. Now, in the tropics, we have some issues. Now, this is our tropical system here in the middle of the Atlantic Ocean. That was a subtropical. Now it's not. But the thing I want to point out to you is this feature right in here. That may become a bit of a problem. Let me show what I'm talking about here. This is the European model here, the afternoon run, day 10. It develops a little bit of a low pressure tropical storm off the coast of Georgia and Florida. Now, if we were to draw our cold fronts in here, we would see, well, there's the low pressure, and the front's coming down like this, and here's high pressure over here. So the front's dropping down, and we have another high kind of this way. So this thing is lacking between systems here. But that's 10 days out. We're not really concerned about it. However, here is the new GFS FV3, and you can see it's got a pretty substantial hurricane in the Bahamas near Miami on the October 9th, and then October 12th, it's actually over Jacksonville, goes right up the Florida Peninsula, if you can believe that. And then it goes over the southeast coast up towards Hatteras, which would be bad news for the Carolinas again, and potentially Virginia. Now, that's a very long way out. No reason to freak out over this, but there are indications. Now, for example, this is the European ensemble, and it does show that in this time frame, day 6 to day 8, there is something which might indicate a tropical depression or tropical storm winds developing in the Caribbean. So this color here represents a 40% chance of that happening. So it's not a high probability. It's just something to keep in mind. Okay. We go further beyond and we take a look at the 11 to 15 day, the pattern does change. We get a big ridge forming over the west coast of North America that drives a trough eastward. The temperature anomalies begin to break down and the cold air comes south and east finally. And this would be October, October, around 15th of October, really the middle of the month. And if we look how this plays out, this is the European Weekly from Monday. This came out this Monday night, October 1st, and you can see the cold air anomalies at this 850. You can see very cold air here, relative to normal, pushing across the Central Plains, the Midwest, into New England, the Great Lakes, Eastern Canada, and you can see it again continuing into mid-October 23rd, a pretty cold pattern over the eastern half of the country. And it pretty much there, the cold blast lasts into like October 15th to 20th, and then there's another redeveloping shot coming in here at the end of the month, as you like I talked about here, October 23rd. The pattern breaks down a little bit, and then even further out in time here, the European weekly, you can see by mid-November it's got a pretty big ridge here and a nice trough over the Midwest here. So give the pattern time. We'll see what happens here. It's definitely going to turn colder after the warm up. There's no reason to freak out over the warm up. It's going to be impressive, but it's not going to last. Okay. Siberian snow cover time. It's October, which means it's time to talk about a Siberian snow cover. Why? Why do we talk about it? Well, because Siberian snow cover in October can relate to the amount of cold air available for the winter months as it comes over the North Pole. So that's why we talk about it. So what you want to see is a rapid buildup of snow cover in Siberia during the month of October. So the image in the upper left here, this is actual October 1st snowfall. All right, and this is valid October 10th. And you can see that this has increased significantly, and this has also expanded significantly. So the snowfall is off to a great start in Siberia. And if we look at the maps for the downstream, we can see this is October 1st, and we can see big system over Korea and Japan and eastern Siberia, which would brought the snow here to Siberia. That system right here I just talked about is why we had that early season snowfall right here, right there. So anyway, I just want to point that out to you. Okay, we go beyond that, and here's day 5. There's a very big system right here. It's going to be a big snowmaker right in there. You can see that, and that goes, intensifies, bombs out over northern China, Manchuria, and eastern Siberia. So that's going to produce significant snow here through day 7. So definitely it's going to get pretty snowy in Siberia pretty early. Big build up there. Let's talk about El Nino briefly. Again, some of you want to talk about that. It's coming, and if we can see the latest information here, again, it definitely looks like a Central Pacific El Nino. This is Siberia, this is region 4, and this is the one by South America. So we want to look at, we can see that it's now almost +5, +4, +5, +4, +5. Only region 1.2 by South America is neutral. So that's pretty darn impressive. So we're very close to getting a beginning of El Nino pattern here. Conditions. And if we look at the subsurface temperatures from last week, we can see again, look at this huge pool of warm water which has developed and pushing up to the surface. So yeah, El Nino is coming. Finally, I want to point out to you that significant announcement from NWS. The GFS F3 model will become the main GFS model in the middle or late January 2019, according to NWS. They made that statement either yesterday or today, I believe. And then finally, there's also been a major upgrade with the Canadian model. They made big changes in the Canadian model back in mid-September, and we can see the significant changes. The first one here is that the Canadian ensemble has increased the resolution from 50 kilometers down to 39 kilometers. So that's a big step for those guys. The second one is the RGEM, which is the regular short-range Canadian model, very good for snowfall and winter storms. In the short range out to 50, goes out to 60 hours. They've changed the severe weather parameters. They get a much tighter grid, so that handles the severe weather a lot better than used to. And they also changed the way the Canadian RGEM model calculates the lifted index, which has to do with thunderstorms and buoyancy in the atmosphere and moisture and convection, that sort of thing. And finally, the other model that they have here is their new super high resolution HRDPS, which is the Canadian answer to the 3-kilometer WRF. New microphysics, much better handling of the urban conditions, and also lifted index was changed there as well. And the impact of this apparently has been significant. Dr. Ryan Mao says that the Environmental Canada has upgraded the models over the past 2 weeks ago, and so far it has really taken off, been a big improvement. And you can see that here he shows the chart, and you can see the Canadian model is the black line here, and you can see that the Canadian model at times is matched up with the British model and the European model, the blue and the green. So the blue and the green European and British model, and you can see the black line has gotten pretty close at times. The red line is a GFS model, and again, it's generally been running a little inferior, as you can see, like it typically does. But and the blue, like I said, the blue line again, that's the European model. You can see it's running the top here, pretty good here, pretty good here. But in the last 10 days or so, the Canadian model has jumped up. Now, it might just be a temporary glitch, so we don't know if these adjustments that the Canadians have made are going to be permanent, but it looks like it's doing a little better than it used to do, and that's good news going into the winter. This is meteorologist DT from Weather Risk. I'll talk to you soon.